Hello everyone, my name is Yasaman and today I want to explain a topic that is really interesting to me. Rare earth elements interaction with organo-mineral colloids as a control of the rare earth elements environmental dissemination. I have three lovely supervisors and this research is about a Panorama project. After completing my bachelor, I undertook my master in nanotechnology at Université, Iran. My master thesis was on the topic of a comparative study on the absorption of nickel ion from industrial effluent by sunflower seed husk and zeolite, which engendered my interests in environmental topics. I started my postmaster fellowship program after graduating. At the same time, I took a job in a wheel production company as the head of engineering department, as I always was motivated to be in academic atmosphere and I was interested in environmental issues. When I found this position, I understood this is what I wanted exactly. In this project, I'm working on rare earth elements and colloids. If you want to know more about rare earth elements, how about you check out the Panorama introduction video. Okay, let's continue with colloids. Colloids are microscopic particles with sizes in the range 1 to 0.01 micrometer. They can be produced by agricultural erosion, wetland, and permafrost thawing. Because of their small size, they tend not to settle out of suspensions. Among them, FeOM aggregates are of major importance due to their higher amounts, their nanometric size, and their specific surface area. Colloids play an important role in the transfer of rare earth elements in the environment over short and long distances. Knowledge of the physical and chemical composition of environmental colloids involved in rare earth elements transfer is important if the relevant processes are to be understood and accurately remodeled. I synthesized the FeOM colloid in the lab with non-ardent humic acid. The PhD aims to explore the intimate bonds linking rare earth elements to heterogeneous colloids with or without folliculating ions like calcium, as well as the colloid heteroaggregation impact on the rare earth elements mobility. Cutting-edge research tools like DLS and TEM will be used to characterize colloids. As a second step, I want to investigate bonding between rare earth elements and colloids. I will use coupling field flow fractionation, QQ ICP-MS, and X-ray absorption spectroscopy to understand the mechanism of rare earth elements binding to colloids. I want to find out the answer of this question. How is the rare earth elements distribution in different concentration and which mechanisms involved in their bindings? Of course, we will have different binding mechanisms under flow condition. To simulate this condition, we will use a microfluidic device and will investigate binding mechanisms at equilibrium condition and the output of the device in microscale transport. I hope you are as interested in this subject as I am. I'll keep you updated about my results in near future. You can get in touch with me for any further information by this email address. See you soon. Bye.